Hi guys, welcome back to the part 4 of the NLP lecture. In the previous lecture, so far we are done with the term frequency, which is how many times a word appeared in SMS. Like in the message 18, this way appeared 2 times. Now it's time to compute for term weighting and normalization using TF-IDF. Once again, recall your understanding of TF-IDF from the theory lecture. So moving forward, Scikit-learn provides a tool, TF-IDF transformer, to do this task. Let's import TF-IDF transformer from scikit-learn.featureExtraction.txt. So from sklearn dot feature extraction dot text import T with capital T FID transformer, and let's run this cell. Let's create its instance now. So TFIDF underscore trans is going to be our instance for TFIDF transformer. Let's run this cell, and now we have instance TFID. Let's do it IDF here and rerun this cell. So now TFIDF underscore trans is our instance for TFIDF transformer. Let's add few cells. So now we can call fit using this instance and pass in our df underscore BOW, which is our matrix of token counts. So TFIDF underscore trans dot fit and pass in df underscore bag of words and run this cell. And here we have the output. So as previously done, for better understanding, let's work with a single message, which is SMS underscore 18 once again, and transform BOW underscore 18 to TFIDF. So TFIDF for message 18 is going to be TFIDF trans, which is our instance fitted on df underscore bag of words, and we call transform here, and pass in the thing that we want to transform to TFIDF. And here we want to transform BOW 18, bag of word, for message number 18. So BOW 18 and run this cell. Let's check how TFIDF 18 looks like now. We can call print again and run this cell. So here we have the word at ID 1097 and its weighted value. So these are the weighted value of each of the word in SMS 18, which is the relationship between TF and IDF, term frequency and inverse document frequency. We can check IDF for any single random word as well. Let's try the one which came twice in SMS underscore 18, and that word was way. Let's add few cells to make some space. TFIDF underscore trans dot IDF underscore and pass in the ID for way. Either we can grab the ID for way, or we can call BOW transformer dot vocabulary and pass in way. This is going to give us the ID for way. Let's run this cell, and here we have IDF for way, which is 5.06. Now after working with a single message, we got better idea on weighting. We can transform the entire bag of word, which is df underscore BOW, to TFIDF corpus now. So instead of passing a bag of word for single SMS, we need to pass in a bag of word for the entire corpus. So let's do this thing now. So df TFIDF So TF-IDF for entire data frame is going to be TF-IDF underscore trans, which is our instance, this one, and this one on the single message as well. So TF-IDF underscore trans dot transform. And what we need to pass in? df underscore BOW. And let's run this cell. Now here we have the TF-IDF for the entire data frame. Let's check its shape. So df underscore TF-IDF dot shape and run this cell. So we have 5572 by 11,425 matrix. So we're ready for machine learning now. We have transformed our data into its vector form. We can train our machine learning algorithm now. Once again, it's a spam and ham detection, which is a classification problem. We have already learned several models for classification problem. We can use any one of them. However, naive Bayes is considered as a good choice in text retrieval community. With appropriate pre-processing, naive Bayes is competitive in this domain with more advanced methods including support vector machines. You can follow the link provided in the reference notebook to learn more. Moving forward, let's use the one which is accepted by the experts as a better choice and import multinomial naive Bayes model, which is multinomial NB from Scikit-learn. So we need to do another import here. Let's add few cells again and do another import. So from Scikit-learn dot naive Bayes import multinomial NB, and let's run this cell. As always, let's create its instance, and we can call instance spam ham detection. Spam ham detection is going to be multinomial NB's instance. Let's run this cell, and now we have instance spam underscore ham detection for multinomial NB. If you remember from the previous sections, the next step in machine learning is the splitting of your data into train and test. We need to separate features and target values now to do this train test split. So we need to do another import from Scikit-learn dot model selection import train test split and run this cell. Let's separate features, which is X is always our features. In this case, we have df underscore TF-IDF as X, and Y is our target column. df target. Let's run this cell. Now we have X and Y as well. Let's do the split here. Train test split. Press Shift Tab, go to the end of the documentation and copy the code to save some time. And here we have. Let's do some adjustments here, and now we can leave the test size 0.33 and random state 0.42 and run this cell. Now we have X train, X test, Y train, and Y test. The next step in machine learning is training your model. You have an instance. To train this model, you have to call fit on the instance and pass in the trained dataset. So spam ham detection dot fit and pass in X train and Y train. And let's run this cell. Now we have trained our model on the training dataset. The next step is always evaluation. Let's add few cells and move on towards the evaluation. Let's do the predictions now. So pred is going to be spam ham detection dot predict and pass in the test dataset and run this cell. Now we have predictions in pred, whereas we have the actual values for spam and ham in y test. We can print confusion matrix and classification report to see how our model worked. For this purpose, we need to do another import here. So from Scikit-learn dot matrices import classification report and confusion matrix. Let's run this cell and print the confusion matrix, pass in y test and pred. Then print the classification report as well, pass in y test and pred. Let's run this cell, and here we got very good results. The model is doing very good. Our precision, recall, F1 score and confusion matrix is quite reasonable. So our model is performing quite well. So moving forward, let me introduce another very important concept here, which is pipeline. In the machine learning section, we have used vectorized form of our data frame, which is df underscore tfidf. This is not what we usually do. We did this here because we wanted to follow the flow and for learning and training purpose. Scikit provides a great feature of its pipeline capabilities to store a pipeline of workflow. The purpose of the pipeline is to assemble several steps that can be cross-validated together while setting different parameters. We can set up all the transformation we did during the text processing in a single unit using pipeline feature of Scikit-learn. Rather than doing all steps one by one, we can then call that single unit for our data processing. In this way, we save lots of time and there is no need to redo all the transformation steps manually. A simple call for pipeline object with stored steps on the data will do all the processing in future. So I'm going to split this lecture here and we will continue in the next lecture to learn more about the pipelines. See you in the next lecture. Good luck.